Assalamualaikum, Dr. Nur Suharayani. My name is Norina binti Leban Muhammad Nasir, and my matrix number is CE200173. We want to present our group assignment for this is our group team members. So okay, in this assignment, we are required to find the minimum of the 30 or at least 30 real data from online internet sources and also PSM student thesis. So we have already find the data. Okay, we have find it. This is the link of the data that we have find it, and we get a 48 data of engineering data, and it's about the temperature and relative humidity datasets for a seminar room. So as you can see, the independence X is temperature, for the dependent Y is relative humidity. Okay, let's go through the questions. And the question is state the mean standard deviations, minimum and maximum value for the independence and dependence value. So as you can see, we have already using a software SPSS software to find the mean standard deviations, minimum and maximum for the independence and dependence. So as you can see, the end of the step size meaning is sample size is 48, and for the temperature, the mean is 22.615, and the standard deviation is 0.8681, and the relative humidity is the mean is 43.854, and the standard deviation is 3.6611. So the maximum and minimum. So we also do the manual calculation to find the mean standard deviations. So the temperature for the mean is summations at divided by n, and we get 22.6146. And to find the standard deviations, we need to find the variance first. So we get a variance answer, and we need to square root for the standard deviation. So we get 0.8681. Same goes to the relative humidity. We need to find the mean, variance, and also standard deviations. Okay, for the next questions, question B is sketch a scattered diagram and regressions line of for the data. So as you can see, we have already sketched the scattered diagram, and as you can see, the equations is y equal to 31.72 plus 0.548 x, and the r squared linear is equal to 0.016. So that's all from me. I will pass to the next presenter. Thank you.
Hi, my name is Muhammad Jokli Binteli, number matrix CE200038. So in this video, I'm going to present for the question C and D. So for the question C, we have the simulation and also the manual calculation. So first, let me go to the simulation. Okay, so as you can see, this is our ISPP software. So I have insert all the data into this table with our independent value is temperature and dependent value is relative humidity. So our question is, assuming a linear relationship, use the least square method to find the simple linear regression model. So basically we need to use the least square method to make the simple linear regression model. So first we need to go to the analyze, and then regression, and then we go to the linear. So in this we need to insert our dependent value, so which is our relative humidity, and then our temperature for our independent. And after this we just we go to the statistic, and then we click click on this, and then continue, and then okay. After that, it will show our output here. So this is our result. We have descriptive statistic, correlation, variable, model summary, ANOVA, coefficient, and cognitive diagnostic. Okay, so for the manual calculation, so the first thing that we need to determine the value for sum of y, sum of z, sum of sum of x, sum of y square, sum of x square, sum of x multiply with y, and then our n, which is our, what we call this, our number of table. So for the xxx we get is 45.5148. For the sxy we get 29.4104. And then at the end we get for beta 1 is 0.53648, and beta 0 is 31.72185. So the equation for our least square line is y is equal to b beta 0 plus with beta 1 x. So this is our equation, which if you see on our simulation, the the coefficient we get 31.082, but in this one you get 31.72185. Okay, so I think that that's wait. So for question D, the question is check the significance alpha 0.05 of the simple linear regression model. So for this one, we just refer to the ANOVA table, which is this one. So as you can see, the ANOVA table is used to determine whether our model is significant model or not. P is the significant value. If the significant value is less than alpha 0.05, we can say that the model is significant. Based on the ANOVA table above, our significant value is 0.389, which is more than 0.05. To determine the discharge of the slope is significant or not, we can see the value of the significance is 0.359, which is more than alpha 0.05. So we can say that it is not significant. So that's all from me. Thank you very much.
Hello, my name is Gabriel Ruchi bin Momin, matrix number CE200014, and I will continue to present for the question E. Okay, this is our IBM SPSS statistic data table that we get from the journal that we take. Okay, after we put all the value and the data inside, we go to the analysis, regression, and we go for the linear. And I already done before, and this is our table and data that we need. So for my part is for the coefficient, it will be generate auto generate. So this is our data that we get from the SPSS just now for the coefficient, and this is our report, and the constant value that we get between the regression line and y-axis is 31.082, and the slope and the or the gradient of line number describe both direction steepness of the line where the value is 0.566. So in this case, we can say that the data of the humidity in the room is not really caused by the temperature of the room. It can caused by many causes, many cases, but not truly affected or truly caused by the temperature. So that's all from me. Thank you.
name is Mama Hashim Samri. So, the assignment video report, I will present about question G, F, G, and H. Okay, for question F, where we need to determine the hypothesis where H naught equals to beta naught is not equals to 0, and H naught equals to beta 1 is not equals to 0. Okay, so for the H naught, step 1, state hypothesis. Okay, so H naught B naught is equals to 0, H naught B naught is equals to 0. So claim. Okay, write all the information. This is a two-tailed test. By using the table, the critical value is x bar 43.8541 and 48 sigma 3.6611, where alpha equals to 5% and 0.025. So critical value is alpha over 2 v, where we get 48 minus 1, we get 47. We get 2.0 plus minus 2.0. So this is the graph 2.0 and negative 2.0 and 2.0. So this is the decision rule, except H naught if t test falls in the rejection region, where negative 2.0 critical value more than 2.0. Okay. Step 3. Use t test. T test x bar minus mean over sigma over square root of n. Okay, 43.8541 minus 32.6146 over 3.6611 over square root of 48. So we will get 40.19. So the decision, step 4 decision, the test value is 40.19, which is greater than the critical value. This equals to 2.0. The decision is to reject the H naught. So conclusion, there is enough evidence to support the claim that H naught equals to B naught not equals to 0. Okay, next. For the next hypothesis, we can test hypothesis H1 beta 1 is equal to 0 by taking 5% level of significance, where the hypothesis can be tested by using y equals to beta naught plus beta 1 x plus error, where beta naught constant, beta 1 slope regression coefficient, y independent data, x is dependent data, and uh, this one is error. Okay, for step 1, state the hypothesis. Okay, H naught equals to B1 equals to 1, and H naught equals to B1 is not equals to 1. This is the claim 1. Okay, write the information. This is the two-tailed test. By using the T table, the critical value is T A over 2 V, which is T 0.025. 47, we get plus minus also 2.00. Decision rule, accept H naught if accept H naught if T test fall into the rejection region, when negative 2, K value 2. Okay, step 3, we need to compute MSC and t-test. So for summation of x, we will get 1085.5. Summation of y, we will get 2105. For summation of x times y, we will get 47622.7. For summation of x squared, we will get 24583.55. And summation of y squared, we will get 92,943, and where n is most important, which is 48. So first, calculate xxy, xxx, and syy. Calculate xxx. Xxx, summation of x squared minus 1 over n, summation of x squared. So xxx equals to 34.583.55 minus 1 over 48 minus 1 over 48 times 1085.5 square. So x-axis equals to 35.4198. So sxy, summation of xy minus 1 over n, where times summation of x and summation of y, where we get xxy 47.622.7 minus 1 over 48 times 1085.5 times 2105. And then we will get xxy 1 and 19.0021. So to calculate SYY, SYY equals to summation of y square minus summation of y square over n. So 92,943 minus 2105 square over 48. Then we will get 629.9791. So compute the MST and t test. Beta 1 xxy over xxx beta 1 equals to 19.0021 over 35.4198. Beta 1 we will get 0.5365. So for the y-intercept, B note, summation of y over n minus beta 1 summation of x over n. So beta note equals to 2105 over 48 minus 0.5365 times 1085.5 over 48. So beta naught equals to 31.7214. So here SSE, SYY minus beta 1 times XXY. So SSE equals to 629.9791 minus 0.5365 times 19.0021. SSE equals to 619.7844. So for the MSE, SSE over n minus 2, and MSE will get 619.7844 over 48 minus 2, which is 46. We will get 13.474. So for the t-test, we will do 2 times, which is for test 1, t-test 1, beta 1 minus beta c over square root of MAC over XSX. We will get 0.5365 minus 0 over square root of 13.474 over 35.4198. We will get 0.8699. For test 2, beta naught minus beta c over square root of square of MSE over 1 over n plus x plus square over xsx. For test 2, 31.724214 minus 0 over 13.474 times 1 over 48 plus 1085.5 over 48 square over 35.4198. Then we will get the answer 2.272. Step 4, make a decision. So we will reject H note because t test 1 less than critical value, which is 0.8699 less than 2.0. Step 5, make conclusion. Enough evidence to support the claim because except H naught equals to beta 1 is not equals to 1 because t test less than 1. Compute the coefficient of Pearson correlation and interpret the meaning. Okay. So the correlations, temperature, Pearson correlation 1, relative humidity 0.217, sigma total 0, and relative humidity 0.389, temperature Cn, temperature and number sample also 48. So relative humidity Pearson correlation 0.127, 1, sigma total, temperature 3.89, relative humidity 0. So manual calculations R equals to xxy over square root of sxx times xyy. So xxy is 19.0021, xxy equals to 35.4198, syy equals to 629.9791. We will get 0.217, is 0.127. So the meaning is Pearson correlation coefficient can be computed by measuring the strength and direction of a linear relationship between indoor temperature and relative humidity in a positive sign. So for H, compute the coefficient of determination and interpret the meaning. So the model summary R equals to 0.127, right, which when we R square it, we will get 0.016. Okay, so the coefficient of determination R square is a number between 0 and 1 that measures how well a statistical model predicts an outcome. You can interpret the R square as a proportion of variation in the dependent variable that is predicted by the statistical model. As for the model, since R2 equals to 0.016, initially times about 100 equals to 1.6%. Hence, approximately 1.6% of variation in the values of humidity is accounted by inversely proportional relationship with the temperature. Okay, that's all for me. Thank you.